Welcome to the Greater Yellowstone Ecosystem, the Circle of Life. The Greater Yellowstone Ecosystem is one of my favorite places in the world. I was introduced to the area by my good friend Alan Tobin back in 1980, and I've returned to the ecosystem almost every summer since then. For years, I struggled really whether to offer this class or not, primarily because fewer people going to the area meant less impact on the ecosystem, but also there was a selfish reason. Fewer people going to the Greater Yellowstone Ecosystem was good for me, because part of the reason I went up there was try to get away from people, to go to remote areas. But I eventually came to really a different conclusion. And I realized that as I looked at my own life, human population had grown from 2.7 billion people in 1954 when I was born to the 7 billion people that are on the planet now. And so the ecosystem is increasingly under pressure from humanity. And there's a certain reality, and it is that to know the Yellowstone ecosystem is to love the ecosystem and to want to protect the ecosystem. This class essentially was born as a field class back in 1995. I started with another instructor here at Palomar College. And that was the first year that the wolves were reintroduced to the Yellowstone ecosystem. We were fortunate enough to actually see one that year, and we've seen them every year since. So this class then is a natural progression, an opportunity to reach a larger audience, educate the American people about this ecological jewel, and the risks that threaten the ecosystem. And additionally, really to prompt you to go there. I'm going to show you lots of things in this class, but you have to see it for yourself to really appreciate it. And again, once you do, you will love it and you will want to protect it. So we're fortunate enough here at Palomar College to actually have a field laboratory that goes there, but regardless, you have to go there to appreciate the place. So at its core, this class is a biology class, however. So we will be talking about the biological processes that relate to the Greater Yellowstone ecosystem. So this includes chemistry, biochemistry, energetics, genetics, evolution, systematics, and ecology. And we will also consider some of the management problems associated with the Greater Yellowstone ecosystem and the influences on those management problems, which include growing population, local and state economics, local, state, and national politics, and recreational pressures. So my ultimate goals are then that you will understand the processes that underlie the phenomena that you see in the ecosystem, that you will be able to identify a number of plants and animals in the ecosystem, that you will be able to recognize the different types of ecosystems there and also the transitions between those ecosystems. That you will be able to describe the many management issues unique to the ecosystem and the local, state, and national influences on that management of the ecosystem. And finally, as I stated at the outset, that the familiarity that you gain with the ecosystem through the class will instill a desire to protect the ecosystem. All right then, so where is the Yellowstone ecosystem? What is the Yellowstone ecosystem? The Yellowstone ecosystem is found in the northwest corner of Wyoming. It also involves states or goes into the states of Montana and Idaho. And kind of at the center of the ecosystem is the Yellowstone National Park, and to the south, Grand Teton National Park. But the national parks are buffered by some other national lands of various types. And so, as you can see here, that includes national forests. So there are a number of national forests, as well as in red here, showing us some various wilderness areas. And then as we expand out beyond that, there's also what we would call Bureau of Land Management properties as well. And that's true in the south as well. Again, so Teton National Park is buffered by both national forests and various wilderness areas as well, and I'll get a chance later in the course to talk about some of the differences between these different types of regulating agencies and the lands that they manage. So as we look at the Greater Yellowstone ecosystem, it can be defined in some various ways. Depending on how you want to define it, it's somewhere between 5 to 18 million acres. So that's pretty big, but it really sounds bigger than it is when you go there. Also, as far as ecosystems go, this is considered a relatively simple ecosystem. Yet, when you look at what makes up the ecosystem, there are 67 species of mammals, including wolverine and lynx, which are really highly endangered animals. There are 322 species of birds, 16 species of fish, 11 of which are native, 10 species of reptiles and amphibians, at least 12,000 species of insects, and 1,100 native vascular plant species. So again, keep in mind this is a simple ecosystem, yet we still have this extraordinary diversity, and we'll be learning about a lot of these organisms in the course of the class. So I first want to look at the national parks and talk a little bit about both their geologic history and also their human history and how they came to be. So beginning with Yellowstone National Park. If we look at Yellowstone National Park, it's known for its geology, and this is certainly not a geology class, but we will occasionally be referencing geology as it relates to the biology that we observe. And so in Yellowstone then, we will observe a number of different types of rock. Sedimentary rock, this is an area that at one time was under an ancient sea, so we'll see some evidence of that. Igneous rock is volcanic rock, and there's tremendous diversity of igneous rocks in the Yellowstone ecosystem. Metamorphic rocks, either igneous or sedimentary rocks that have been cooked in various ways and modified. We'll also discuss to some degree the effects of glacial activity, and again, if you were to go to the park, you'd see a lot of evidence of glacial activity in this area. And then also, of course, there's tremendous geothermal activity in the park, and that's really what attracts people to this area a lot of times, is to look at that geothermal activity. But again, our reference to this will be primarily as it relates to biological systems. So in terms of looking at the park itself and some of this geology, a lot of it relates to the fact that Yellowstone sits over what we call a hotspot. And so in this hotspot, what we have is magma that is a dome of magma, which basically has moved up under the Yellowstone ecosystem. And again, this is what's driving a lot of the geothermal activity that we see there. Now, Yellowstone also sits on, and part of the park is made up of what we call a caldera. And so there have been several massive explosions which have occurred over time here. And basically what happens in these kinds of situations is, as this magma dome rises, what that does is push up the crust in that area. And as it turns out, this magma in the area is under, or contains a lot of gases. And because of the overlying sediments, that gas will be under tremendous pressure. So as the crust rises up, it cracks and splits. That then allows the pressure to dissipate, and so the gases will expand, and that leads to a massive explosion. And that's the same kind of thing that happened in the Mount St. Helens area. So in the last 2.1 million years, there have been 3 massive explosions. And again, when this explosion occurs, that leaves a crater, and that crater then has been filled in by various activities. Some of it's been filled in by magmatic flows, or flows of magma and lava, on the surface. And then, again, there's been a lot of erosion and other activities which have smoothed over that scar. But again, that scar still exists. So as we look at the Yellowstone ecosystem, the most recent of these explosions was about 650,000 years ago. And again, there's a much larger caldera, which there's some remnant of from about 2.1 million years ago. There's also another caldera a little bit further to the west from about 1.3 million years ago. So over the last 2.1 million years, there have been about 3 of these large explosions. They occur about every 650,000 years or so. So we're more or less on schedule then to have another massive explosion. And again, this is really a concern, because when you look at the size of these explosions compared to one that we know in this country, the Mount St. Helens explosion, when Mount St. Helens exploded, only about 0.1 cubic miles of debris was generated from that explosion. Now, to compare that to the explosion 640,000 years ago, which forms the kind of the current caldera, the most recent caldera, that unloaded about 240 cubic miles of debris, and the one 2.1 million years ago released about 600 cubic miles of debris. So I think you can imagine that if there was to be another massive explosion, it would change life for probably everybody on Earth. This is a really major kind of problem potentially in the future, but hopefully not in the recent future. All right, so again, it's this magmatic dome then, this hotspot, which is responsible for a lot of the geothermal features which we do see in the park, and we see a lot of these when we go up there. So these include hot springs. And some of the hot springs are just extraordinarily beautiful, not for just the minerals that we see in the water, but also the living things that we find in the hot springs, and we'll be talking about that in future modules. but again, a number of different types of hot springs throughout the park. Also geysers, Old Faithful is probably the most famous of the geysers in the park, but there are others, and again, they're just spectacular. Water is released, it will drain back into the vent and eventually be spewed again. Fumaroles, which vent steam. And then also we have mud pots in the park as well. And so there is kind of an odor to Yellowstone, if you will, and it's caused by the sulfurous gases that are produced, hydrogen sulfide primarily, which has kind of a rotten egg smell. But again, it doesn't permeate everything, and the view and the wildlife is well worth that odor that we occasionally encounter. So looking at human history of the park and human use of the park then, there's evidence of human use dating back to 11 to 12,000 years ago. And this is when kind of the last of the glaciers receded from the area. And use certainly has ebbed and flowed over time in the park, having to do with climate. Most of the use has been summer use in the park. There's also, when we look at how the region was named, Yellowstone, there's a lot of variations of this story, but what seems to be the most reliable is that Native Americans in the area referred to the river that runs through the area as the River of the Yellow Rock. And then as French trappers came to the area, they kind of modified that translation to the river of, or the canyon of, or the area of the Yellowstone. And then this stuck when that was translated from the French trappers into English. And so again, there was quite a bit of use of the park, but it declined a little bit from about 1400 to the mid 1800s, because there was a little bit of a mini ice age there. But again, most of the use of the park has been summer use in the park. And so again, there's quite a bit of evidence of that. So again, as we look at the park, one of the areas where you really see this Yellowstone appearance is in the Grand Canyon of the Yellowstone. And this is a place where we see a volcanic rock known as rhyolitic rock. It produces a rhyolitic soil, and that rhyolite is kind of yellowish in appearance. And so that's what gives the area its name, we think. All right, now also as we look at use of the park by humans, and particularly the Native Americans, one of the things that they build along the shores of Lake Yellowstone, so here's Lake Yellowstone down here, as you travel along Lake Yellowstone, you'll actually see evidence of what are called fish traps there. And so anyway, what the Native Americans did is that when water levels were low in the summer, they would build berms along the shoreline. And then what would happen is in the spring melt, water levels would rise. And when the water levels dropped again in the subsequent summers, that would trap water here, and that would also leave fish in there as well. And so then they could just literally wade in and collect any fish that were trapped in these areas. So again, you'll see a lot of evidence of that all along the shores of Lake Yellowstone, where there are some shallow regions there. There were a number of Native American tribes that took advantage of the area. The Kiowas, Blackfeets, Cayuse, Coeur d'Alenes, Bannocks, Nez Perce, Umatilla, Crow, and the Shoshones. And the Shoshone in particular, there was a group of Shoshone known as the sheep eaters. And they're kind of interesting because they would actually follow the bighorn sheep migrations in the park, and were really skilled hunters of bighorn sheep. And actually it's a tribe that even after use of the horse had been introduced to many of the cultures there, that they actually did not use the horse. And they actually, like I said, stayed in mountainous regions and followed the bighorn sheep. They were also known for taking the horns of the bighorn sheep. They would soak the horns and then cut off this kind of flat portion of the horn and make bows from that. And so they would trade these bows with other tribes. And so these were really extremely powerful bows, and there are stories that the bows were powerful enough to actually send an arrow all the way through bison. So anyway, so again, they're kind of one of the better known tribes that lived in the area. Now, Europeans then came to the area, certainly by the late 1700s. The area began publicized as these trappers would go back east. And one of the more famous members of this group then was John Coulter. John Coulter was a member of the Lewis and Clark expedition, and as they were returning from that expedition, he asked for permission to leave. He met another trapper who was moving through the area, and so Coulter traveled through the Yellowstone and Teton area and brought back stories about the extraordinary sights that he had seen. The area gained fame, certainly through the 1800s, but it really wasn't until after the Civil War that there became a real interest in preserving this incredibly unique area. And so there were a number of expeditions, one by Folsom in 1869, then Washburn 1870, Hayden followed in 1871. And part of that was that there was a lot of pictures that came out of that final expedition, and also photographs, so paintings and photographs that came out of that last group. And so this eventually led then to Congress deciding to preserve the area. And so Yellowstone National Park was established with the National Park Preservation Act in 1872, and so it is the oldest and the first true national park. Now, as we look at the Teton area then is Grand Teton National Park is south of Yellowstone National Park. And Grand Teton National Park really is a very different park in a lot of ways. The geology is somewhat different there. Also, certainly the human history is different in recent history in terms of when the park was established and so on. So as we look at Teton Park, it's going to be composed of the Teton Range. Also, there's a series of alpine lakes at its base. And then also there's a large valley to the east, which is known as the Jackson Hole. So a hole is a valley that's surrounded by mountains, and basically this whole area is surrounded by mountains, so this area is known as the Jackson Hole. And the Snake River runs through Jackson Hole. So again, we can see the Teton Range here, and Grand Teton National Park is named for the highest peak in the park, which is the Grand Teton. And that is French for large breast. So anyway, Grand Teton National Park. Now, as we look at some of the geology of the area then, again, it has to do with, formation of this mountain range and also the Jackson Hole area off to the west. And so when you look at the range, there's actually a fault which runs along the base of the range, and it's visible in some places. And so what's happening then is the range has been rising and the floor of the valley has been dropping away. And so as we consider that then, there's basically a fault line there. And so again, what's happened is that the valley has slid down and dropped down as the mountain range has increased. And then there's also again been a lot of glacial activity in this area. And so glaciers have covered this area at times, over a mile thick. And with that and then receded, and what they left behind was a lot of debris in the valley. And so anyway, and then also the Snake River has developed since that time as well. So there is soil in the valley, but what's kind of interesting about it is you look at the valley and it looks, beautiful, looks like it should be a really good agricultural area and so on. But the soil that's there is really very, very thin. There's just a few feet of soil at best. And after you dig down through that, you're basically just looking at glacial rock, glacial till. And it's kind of interesting. So when we look at formation of Grand Teton National Park, again, it's a much more recent history in terms of that park. So proposals to preserve the area actually began back in the 1800s, about the time that Yellowstone was being formed, because it was felt that there needed to be an expansion of the Yellowstone area to include the migration routes primarily of the elk herds that frequented the southern part of Yellowstone Park. And by 1929, then the Teton Range and the lakes at the base of the range had been set aside as a national monument. But people, enthusiasts of the area, a lot of them felt that that wasn't adequate. And one of these people was John D. Rockefeller Jr. of the famous Rockefeller family. And so he wanted to help preserve a larger area, especially the Jackson Hole area. Now, the Jackson Hole area was used primarily by ranchers, and it was there were a lot of economic interest in that. And so Rockefeller formed basically a phony company to buy up property under the guise of starting a new ranching company. And this was known as the Snake River Land Company. And so he began to buy up land and bought something like 35,000 acres, I believe 37,000 acres over time. And then he attempted to donate this to the government. And believe it or not, this was a really contentious issue, and it actually took a long time before they actually accepted that donation. And it wasn't until 1950 that Grand Teton National Park was actually formed, and it included the land that had been contributed by the Snake River Land Company, as well as the existing national monument. And then in 1972, there was a memorial parkway, which also was added to the park system there, and it's known as the John D. Rockefeller Memorial Parkway. And that links Teton Park with Yellowstone National Park. So we have a continuum, essentially, of the national park system from Teton Park up through Yellowstone Park. All right, so what then constitutes an ecosystem? So as we look at the Greater Yellowstone Ecosystem, what is an ecosystem? Well, when you look at an ecosystem, there are certain abiotic factors. And these abiotic factors then are non-living components of an ecosystem. And abiotic factors would include atmosphere, which is the air in an ecosystem. And so atmosphere can be the air that we breathe. It can also be air and water. It can be air in any form that we find it. So again, it could be the air that we breathe. It can be air trapped in soil, and so on. Now, the hydrosphere would be water in any of its form that we happen to find it. And so, again, that can be flowing water or standing water. It can be water vapor. And so we will find water in a number of different forms. It could be ice. So again, hydrosphere would be water in any of its many forms. Clouds would be another example. The lithosphere constitutes the soil or rocky portion of any ecosystem. So again, soil, rock, dust in the air, sediments flowing in water. Any of this would constitute lithosphere. And then also another abiotic factor, which is an important factor, is energy. So again, energy in its many forms: chemical energy, heat energy, solar energy, and we'll be talking about those many forms as we work through the class. Additionally, then, we also have the living components of an ecosystem, and so that includes organisms. And so an organism is the individual living thing. And like organisms in an ecosystem, so again, could be a bison, that would be an organism, could be the cowbird, that would be an organism, it could be a species of grass. A population would be a collection of like organisms. So we have in Yellowstone ecosystems populations of bison and elk and all kinds of different organisms. But when we talk about a population, we're talking about like organisms, similar organisms. And then populations in turn form a natural community of organisms. So again, a natural community would be, in this case, we'd be looking at bison, cowbirds potentially, grasses, sagebrush, all interacting with one another. That constitutes a natural community. And then finally, if we take a natural community and conclude a natural community of organisms with the physical habitat, that forms an ecosystem. So a natural community of organisms interacting with one another and their habitat constitutes an ecosystem. So when we look at the Greater Yellowstone ecosystem, it's really a bit of a misnomer, because when we're looking at the Greater Yellowstone ecosystem, it's actually better termed a landscape. So a landscape would be a geographic area composed of a number of different ecosystems. And an example of that is if you were to head out into the Lamar Valley of the Yellowstone ecosystem. If we were to take a drive through that, we would actually see some different ecosystems here. So there's a sagebrush community, sagebrush ecosystem here in the foreground. Up on the hills, we're looking at lodgepole pine forest, and lodgepole pine would be a separate ecosystem. So the fact is that we have a blending of different ecosystems. We have our coniferous forest blending into some grasslands through the valley, and then up behind the camera here, you'd be back up into sagebrush community. So we're really not looking at an ecosystem when we talk about the Greater Yellowstone ecosystem. It's really better termed a landscape. So unfortunately, the area is just referred to as the Greater Yellowstone ecosystem, but I should be calling it the Greater Yellowstone landscape. And then if you were to take all of the ecosystems on the planet, combine those, we refer to that as the biosphere. So the Greater Yellowstone landscape is part of the biosphere on the planet. So when we consider the ecosystem then, and one of the themes of the course that we'll come back to periodically then, is it's important to understand then that the physical components of the ecosystem, the matter, atoms, molecules, and so on in an ecosystem, they're going to cycle in the ecosystem. And so we're going to be talking about food chains. We're going to be talking about how organisms feed on one another and so on. And there's also these geochemical cycles that will return nutrients to the soil. And so the atoms and molecules of an ecosystem then get reused constantly, and those will recycle in an ecosystem. But what doesn't recycle in an ecosystem, or in this case our landscape, is energy. So energy cannot be recycled in the same form. And so this is an idea that I'll come back to several times as we work through the class. So matter recycles, energy flows through the ecosystem. But fortunately, we have basically a limitless supply of energy. So we will be talking about a number of different types of ecosystems. Just to give you a very brief overview, we will be, eventually be talking about lake ecosystems, which we call lentic ecosystems. We'll be talking about ecosystems associated with rivers and streams, which are lotic ecosystems. We'll be talking about riparian ecosystems, those that are associated with rivers and streams. We'll be talking about a number of terrestrial ecosystems in the park. And when we talk about terrestrial ecosystems, we'll be interested in the influence of climate. We're going to be interested in the geology of an area, the geography of an area, the latitude of an area, the altitudes at different parts of the park, how those influence then the producers or plants that we find in the ecosystem, which will in turn influence the type of consumers or animals that we find in the ecosystem. And also, there are feedback mechanisms in the ecosystems that we'll have to consider and explore down the line as well. And so there are a number of biomes: deciduous forests, broadleaf forests of one type or another. There are coniferous forests of a variety of types. Different types of pine: lodgepole, spruce, fir. We'll also be looking at some types of grasslands, not necessarily true grasslands, but some grasslands in the ecosystem. Some of them are quite beautiful with their wildflowers. Chaparral ecosystems, the big sagebrush community is the primary chaparral ecosystem. And there's no real true tundra, but when you get up above tree line, we do have tundra-like ecosystems as well. In addition to that, wetlands. Some of these wetlands are seasonal, some are perennial. So again, around some of the lakes and streams, we'll find willow flats, which are examples of wetlands. So I've just given you a taste, really, of where we're headed in the course then. And I look forward to telling you more about this incredible place.